Okay, we have a Chapter 7 practice quiz. The first few problems involve solving. And of course, if you ever have an even root, you're going to have plus or minus when you take even roots on both sides. That's what we have for number 1. To get rid of the fourth power, we have to take a fourth root. But of course, we're going to have a plus or a minus whenever we do that. So if we're taking a second root, a sixth root, whatever it might be, it's going to be plus or minus. Now, really, I lost that negative in there. It's the fourth root of negative 16. Now look, I hope you're going to know there's actually no solution to that. But even if you forgot, if we take 4, we hit math, come down over here, this makes the fourth root appear. The plus minus would be out in front. But we'd see that there's no solution. You can't take a even root of a negative number. So if you take a square root of a negative number, a fourth root or a sixth root, you'd get no real root or no real solution. So that's what we want to have. For number 2, to get rid of a third power, we're going to take a third root. Negatives are allowed inside of odd roots here. So the cube root of negative 125, that is going to be worked out. We can see very quickly if we took this third root, negative 125, you just get negative 5. Only one answer. You don't do plus or minus. Take a look at number 4. We're going to have to take a fourth root to get rid of that fourth power, much like we did for number 1. And we're still going to have that plus minus there. But look what we can do. We'll say 4, math, bring this down here. For number 5, the 4 now is in the index. So the fourth root of 81, we'd get 3. Notice there are two solutions, a plus or a minus 3. As we take a look at number 4, we have a square root. So the second power is indicating we have to have a square root on both sides. So there will be a plus or a minus. And of course, I hope we know that if I took a square root of 81, hopefully we know that right off the top of our head, we'd get 9. So we have plus or minus 9. But very, very, very importantly, that plus or minus is really indicating that we could have x minus 2 is equal to 9, or x minus 2 could equal negative 9. As I solve, as I added 2 to both sides, here or here, you'll see that the two answers that we arrive at are x equals 11 or x equals negative 7. For number 5, rewrite using rational exponents. So we can see the 2's up high, the 7's down here in the index. Very short problem. We'd get 5 to the 2 7's. Number 6, there is an understood index of a 2 down below. So this would become 1 over x to the 5 halves. However, whenever a number or a variable was written down below in that denominator, that was a reciprocal taken, so we can raise that back up to the top, write that as x to the negative 5 halves. Very similarly, with negative powers, we will take reciprocals. For number 7, we rewrite as a radical expression, so we get 1 over 3 to the 5 7's. So this is 1 over the 7th root of 3, raise it up to the 5th power. For number 8, that denominator tells us everything. It tells us we have the 5th root of x, and we're raising it up to the 4th. Once again, you can see this relationship. The 4 is up high just as it is in the fractional exponent. 5 is lower. So wonderfully, you can be done with problems like these in a matter of seconds. For number 9, 8 to the negative 2/3. Well, first let's take a reciprocal, flip that. And you might wonder what 8 to the 2/3 is. We could break it down by hand. But look, if I did 8, hit the caret button, hit alpha, y equals to get a nice fraction there. We'll say 2/3. That's really the cube root of 8 and then squaring it. You get a 4 down below. That 8 to the 2/3, so important to remember that there was a reciprocal taken. It's 1/4. For number 10, let's do a division tree. 54, we can say that we can divide out of 2 and we get 27. 3 goes into 27 9 times. 3 goes into 9 3 times. So we have this cube root of 2 times 3 times 3 times 3. We'll have 5 x's. 1, 2, 3, 4, 5. We'll have 4 y's. And we're going to be in search of 3 of the same number. So that index tells us to look for 3 of the same number or variable. And every time we've got 3 of the same thing, we can circle that. What this really means is out comes a 3, out comes an x, out comes a y. We still have a cube root, but what didn't we circle? Well, we didn't circle the 2. There's an x and an x, that's x squared, and we're left with this y. So very, very importantly, this is still a third root, not a square root. So just break down the factoring, do a little division tree, look for 3 of the same item, and pull it out. For number 11, very similar type of an approach. 18, well, 2 goes into 18 9 times. 3 goes into 9 3 times. So this is really 2 times 3 times 3. Look at 15. Well, 2 doesn't divide in, but a 3 does. That's 3 times 5. And joining these two radicals together, we'll have 2 times 3 times 3 times a 3 times a 5. And here we go again. Do we have 3 of the same number anywhere? Well, we do. We can cross out that 3, bring 1 out. Inside I have a 2 and a 5. 2 times 5 multiplies to a 10. So we'll have 3 times the cube root of 10. For number 12, very first thing I suggest you do is to divide 48 by 2. Turn that into one radical. And we know that 48 divided by 2 can be worked out to just 24. Now we have a much simpler problem to work out. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. So here we have this really nice 2 times 2 times 2 times 3. And here we go again. Do we have 3 of the same number? Well, we do. Take one of them out, cross out the rest. What's left? Well, we just have a 3. This problem becomes 2 times the cube root of 3. For number 13, this 2/3 power is going to be applied everywhere inside the parentheses. We'll take 27, bump it up to the 2/3 power. Powers to powers always get multiplied together. That's a very important property from earlier in the unit. Well, you might wonder what 27 to the 2/3 power is. Look, you don't even have to do the alpha y equals to get the nice pretty print fraction. You can just hit caret 2 divided by 3. You can see pretty quickly that just becomes a 9. 3 times 2/3, hopefully you can do that in your head. If you've had trouble with fractions, you can always multiply that out. 3's cancel. You can see you'd be left with c to the second. Same thing with 6 times 2/3. Well, you get the idea. It's really 12 divided by 3, which becomes a 4. This whole thing becomes 9c squared d to the 4th. For number 14, Well, these are like terms. 2 radical 5 minus 9 radical, fifth root of x. 2 times the fifth root of x minus 9 times the fifth root of x. 2 minus 9 is actually negative 7. So we'll have negative 7 fifth root of x. Okay, moving on. For number 15, you can add a 2 to both sides. Get that radical by itself. How do you get rid of a third root? Well, we raise that up to the third power. And that root cancels. You'll be left with x equals 8. Now, you can store 8. You can hit the store button right here, put it in for x, and make sure that we're right. You have to do a check right now. Always want to do a check when you have radical equations. You've got the cube root of x minus a 2. It's 0. It works. The check is telling us that we're fine. And like I said before, in all honesty, odd roots, that's the time when you could get away with not doing a check, believe it or not. I'd like to show you how to do it just to reinforce the whole checking process. To get rid of a square root, square both sides. You'll have x minus 7 equals 2x plus 3. And then we can minus an x from both sides. You'll have x plus 3 is equal to negative 7. Minus a 3 from both sides, you'll have x is equal to negative 10. Well, let's store negative 10 in for x and see if it checks. I'm going to plug that in on the left side. I'll have the square root of x minus 7. It's no good. I've got a negative inside of the radical. What does that really tell us? There's no solution. You have to be so careful here. This is why we do the check. If there would be an answer, the answer would be negative 10. This problem doesn't even have a solution at all. We're going to divide both sides by 4 to get our x alone. And we'll have 8. 32 divided by 4. To get rid of a fractional exponent, raise it to the reciprocal power. Raise both sides to the 2/3. And again, you could get some help here. 8 to the 2/3, again, you can just go 8 caret 2/3, you get 4. But here we go again. The question is, do we even have an answer at all? Well, let's see. 4, store that in for x. And we're curious if 4x raised up to the 3/2 power is going to help us out here. Sorry, I got a little bit too quick here. How about we just go 3/2? You can see it works. It's going to check out. So the check is good. Got one more. Here's our last one. Divide by 3. Get that radical alone. You've got radical x equals negative 9. You get rid of a square root. Square both sides. In parentheses, negative 9 times negative 9, of course, is 81. You might wonder if this is going to check. It won't. Look, if you type in 3 and then type in radical x, you're going to get positive 27. We should be getting negative 27 if there's an answer. So we'd actually say there's no solution. The check fails.